All right, 4.2, day 2. Okay, we're going to get down to the maybe the nitty-gritty, we might call it, of elementary matrix operations. So today, if you recall, I said we were going to do the last two parts of our objectives. So we're going to perform scalar matrix multiplication, and we're going to solve some matrix equations. So first up, multiplication. The real number factor is called the scalar. So we have an example here, and the scalar is this 3. We're multiplying a 3 by this matrix. All that means is this 3 is being distributed to every number in the matrix. So we're going to have 3 times 2 in that first place, and 1, 1. Then we're going to do 3 times negative 4 in that second place. 3 times 0. And then we're going to do 3 times 7. We do the math for each of these. 3 times 2 is 6. 3 times negative 4 is negative 12. 3 times 0 is 0. And 3 times 7 is 21. So this is our product. Okay. That is scalar multiplication. We're going to be doing that. Okay. But the real number factor is called a scalar. So that number out front is the real number. And so that's why it's called scalar multiplication. So the scalar product, or R, the real number, times matrix A. Okay, so this is the real number, or your scalar. The capital letter here is matrix A, is found, so we're finding this, by multiplying each element of matrix A by the real number. That's truly it for scalar multiplication. Okay, so let's move this up, clear this off and move up so we can do the example A. Again, so example A, or for A, I gave you the example. So we have 1/2 times matrix A. Matrix A is 4, 0, 2, 5. So we're doing 1/2 times 4, right? We distributed 1/2 times 4. 1/2 times 0, we distributed 1/2 times 2, and 1/2 times 5. Okay, so we're just distributing each part of that. So 1/2 times 4 is 2. 1/2 times 0 is 0. 1/2 times 2 is 1. 1/2 times 5 is 5/2. So notice you can have a fraction in here. And this is our final answer. Okay. Notice that our solution, right, we started, A was a 2 by 2, the dimensions were 2 by 2. Our answer is still a 2 by 2. Okay, the dimension shouldn't change at all. All right, so let's look at B. We're going to do negative 5 times matrix B. Okay, so we're going to have negative 5 times B. So it's going to be 2, 4, 1, and 3. Again, if it helps you to grid out like what goes where, feel free to do that because you're going to end up with the same dimension. So if you want to be like, okay, I've got a 2 by 2 here, I've got those 4 places, right? If I just transfer that, that's totally fine. Does not matter in the least. So we're going to do negative 5 times 2 for this first place. And then we're going to go over and we're going to do negative 5 times 4. Then we're going to move down to row 2. Negative 5 times 1. And then the next element, negative 5 times 3. Okay, so then this is going to equal negative 5 times 2 is negative 10. Negative 5 times 4 is negative 20. Negative 5 times 1 is negative 5. Negative 5 times 3 is negative 15. That is our product. We just did scalar multiplication. We scaled it to a different size. All right, C, if you look at C, it's going to take a little bit more work, okay, because we're doing scalar multiplication, 3 times matrix A, and 2 times matrix B, and then we're going to put them together. Now, there's a couple ways you can look at this. Okay, we can do 3A minus positive 2B, okay, or we can do 3A plus negative 2B. Hopefully that makes sense because, again, it's kind of commutative. So we can take the minus sign, we can leave it as a minus sign and just multiply matrix B by a positive 2. Or we can take the minus as a negative, so we multiply matrix B by negative 2, and then we add the two together. It does not matter in the least to me how you do it, okay? But we are going to do the first option, okay? We're going to do the first one, which I know I don't usually do, but that way you can see it. So we're going to take 3 and multiply it by matrix A. So 4, 0, and 2, 5. And then we're going to subtract and do 2 times matrix B. Matrix B is 2, 4, 1, 3. All right, so we're going to walk through this. So for this first matrix, we're going to have 3 times 4. I am going to show you the work still. And 3 times 0. 3 times 2, and 3 times 5. Minus, so I'm leaving the minus, I'm just taking the 2. So I'm going to have 2 times 2, and 2 times 4. 2 times 1, and 2 times 3. Okay, so to begin with, again, showing this step is fantastic. In the future, you don't have to do that. All right, so then I've got 3 times 4 is 12. 3 times 0 is 0. 3 times 2 is 6. 3 times 5 is 15. Minus, we're going to do our multiplication. 2 times 2 is 4. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Then, do you remember how to do subtraction? Okay, we subtract the corresponding elements. So again, I'm going to show my work. 12 minus 4. 0 minus 8. 6 minus 2. So it's 6 minus 2. And 15 minus 6. So we just keep working this down and working this down. So I should put some equal sign here to say, like, all right, I keep going. All right, I'm going to squeeze in my answer. 12 minus 4 is 8. 0 minus 8 is negative 8. 6 minus 2 is 4. 15 minus 6 is 9. Whew, we're down to 1. Oh, sorry. Move my screen there. Down to one last matrix. Again, notice when we started, matrix A was a 2 by 2. Matrix B was a 2 by 2. Our solution is still a 2 by 2. Okay, they keep the same dimensions because they had to be the same in order to add them and or subtract them. Okay, we are cruising right along. Hopefully you're hanging in there. If not, you can always go back and rewatch. Try a couple on your homework and watch it again or whatever, and ask questions in class. Don't forget. Okay, then there's a couple properties of scalar products down here. So our identity property, so 1 times the matrix A is just going to give us matrix A. It's commutative. Okay, so if we have a real number times matrix A, it's the same thing as matrix A times the real number. Okay, scalar products are associative. So we could do 2 different scalars, so R times S, and then multiply by matrix A, or we can do S times matrix A and then multiply by the scalar R. Doesn't matter. Distributive, we didn't have that with addition, right? We distribute. We can do R plus S and then distribute, or is the quantity, R plus S times matrix A, is the same as R times matrix A plus S times matrix A. So whatever numbers you use there. Zero property. So R times the zero matrix is still going to give you the zero matrix. Or 0 times matrix A is going to give you matrix 0. And our closure. So when we have our real number times matrix A, it's still going to be an M times N matrix. It's still going to be closed in brackets and have dimensions to it. Those don't disappear. Okay, now we're going to look at some matrix equations. The variables represent a matrix. Okay, so the variables represent a matrix. So right here, right, that capital X, that is a matrix. And you're going to solve it like any algebraic equation. But you have to remember, the variable is going to get you a matrix. So we're going to have a matrix answer. We're not going to have a nice, neat x equals 2. Okay, we're going to get a matrix. All right, so let's dive in. We want to solve for x in both of these. So if we had an equation, we have this equation, how would we move this matrix? If this was just a number, how would we move this number to this side of our equal sign? We would subtract it, right? Okay, I'm only going to write it one time, so we're going to subtract the matrix 2, 1, 3, 3, 5, 1 from this side. So we subtract it from both sides, so it's going to be gone. We're going to be left with negative 2x equals. All right. So I might do some work out here. Okay, I'm going to show my work to the side here. So you see it. So we're going to do 3 minus 2. 5 minus 1. 2 minus 3. And then row 2. 1 minus 3. Order matters. You have to keep doing it in that order. 4 minus 5. 1 minus 1. Okay, so that's my work. Okay, so I'm going to go back here and get there. So 3 minus 2 is 1. 5 minus 1 is 4. 2 minus 3 is negative 1. Row 2. 1 minus 3 is negative 2. 4 minus 5 is negative 1. 1 minus 1 is 0. Okay, so now I'm sitting at negative 2x equals matrix 1, 4, negative 1, negative 2, negative 1, 0. Okay, so now what do I do to get the variable by itself? Let's be multiplied by negative 2. Okay, we could divide by negative 2. This is true. Or what's the other option? Do you remember? I'm good with either one. We could also multiply by 1/2 because we've talked about scalar like multiplication. We haven't talked about any division. So let's actually use that here. Okay, let's multiply. Instead of dividing, let's multiply by negative 1/2. So we're going to take this and multiply by negative 1/2. Okay, because then these would cancel and we'd be left with matrix X equals. So we're almost done. We're solving for matrix X. All right, this time I'm going to go without doing the work. What's negative 1/2 times 1? Negative 1/2. What's negative 1/2 times 4? Negative 2. What's negative 1/2 times 1? Negative times a negative is a positive. So now we have a positive 1/2. Okay, we're going to keep going. Negative 2 times negative 1/2 is going to be a positive 1. Negative 1/2 times negative 1 is a positive 1/2. Negative 1/2 times 0 is 0. And we close our matrix. So matrix X okay, our solution, because remember, the variable represents a matrix, and that's what we got. Again, we started with a 2 by 3 matrix. We ended with a 2 by 3 matrix. So staying organized in your work is tremendously important. All right, I'm going to erase this work here because it was kind of taking up B's space. And let's go look at B. Okay, so this time we have matrix X plus the matrix 2, -4, -5, 1 equals 2 times matrix 7, 3, -1, 5. Again, if these were numbers, what would you do? Well, 2 is being multiplied by this matrix, so we need to simplify here. Okay, so we're going to have X plus, we need to do our matrix here, 2, -5, -4, 1 equals, let's do our scalar multiplication. 2 times 7 is 14. 2 times 3 is 6. Move to the second row. 2 times -1 is -2. 2 times 5 is 10. All right. What will we do next? We need to subtract. Good, because we have X, this matrix X, minus the matrix that we know. So we're going to subtract the matrix. So I'm going to write it on this side. We're going to subtract 2, -5, and negative. I wrote that a little out of order than I usually do, didn't I? Okay, so we're subtracting our matrix. So we're going to get matrix X equals. All right, 14 minus 2. Right, we're doing corresponding parts. Again, I'm going to do it without showing the work this time. 14 minus 2 is 12. 6 minus -4. Whoa, whoa, whoa. We have minus a negative. That's the same thing as plus. So 6 plus 4 is 10. So you can't forget that minus sign. -2 minus -5. Again, hold up. We have minus a negative. That's plus. So what's -2 plus 5? Okay, good. That's 3. All right. And the last one, 10 minus 1 is 9. There is our solution. Okay. Matrix X is 12, 10, 3, 9. So you've just done in this, both of these, right? You've done some scalar multiplication, you've done addition, subtraction, the whole works. Okay, you're doing all the things we just practiced. All right, now we're going to look at that real world problem. I don't remember how it's worded in our objectives actually. Solving, well, no, we solved matrix equations. Now we're going to do a little bit, dig into that a little bit more. Okay, let me get all my paper in there. So example 6, solid state drives have been replaced, have replaced hard drives in notebook computers and many other devices. An SSD manufacturer tracks the sales data from stores in Boston and Chicago, and the manufacturer wants to increase his total sales by 50%. Okay, so we've got these charts here, right? 120 gigabyte, 256 gigabyte for both Boston and Chicago, and both of them are in the months of June and July. Okay, so that's the thing. This data has to be corresponding. It's 2 different locations, Boston and Chicago, but all the other components that were gathered, the data points, are for corresponding pieces of information, corresponding data. So step A says create matrices B and C representing the sales data from Boston and Chicago. That's easy, right? We're just going to put this in a matrix for Boston, and we're going to put this in a matrix for Chicago. Okay, so matrix B equals 78, 89, and 31, 19. Matrix C equals 102, 97, and 47, 33. Okay, simply pulling that data right out of those charts, which we practiced yesterday. All right, step B, add the matrices to obtain T. Okay, so this is our matrix name, a matrix representing the total sales. So we're going to do, I'm going to write this as an equation. We're going to do B plus C equals T. Okay, you don't technically, again, have to show me necessarily all of the work. Like, especially if you give me this equation and then you want to show me matrix T, okay, I'm cool. I'm okay with that because we're adding corresponding data. So 78 plus 102 is going to give me 180. 89 plus 97 is going to give me 186. Go ahead and put that bracket in there. 31 plus 47 is going to give me 78. And the last element, 19 plus 33 is going to give me 52. So there we have matrix T, the total matrix for all their sales. So they sold 180 120 gigabyte SSDs, or hard drives, no, SSDs in June. They sold 186 SSDs, 120 gigabyte SSDs in July in both Boston and Chicago. Okay. Next up, step C. Create G. So now G is the name of our matrix. A matrix, representing the goal in total sales. Okay, so what is the goal in total sales? We want to increase the total sales by 50%. So we want to sell 100% of what we sold already, and we want to increase or add another 50%, right? So that's 150%. Which we represented by what number, what numerical value? That's not a percent. Okay, that's 1.5, right? So our goal equals 1.5 of the total. 1.5 times our total. So again, if you give me this equation, okay, that's going to be helpful. So we're looking at our scalar is 1.5. and we're multiplying it by matrix T. So this one, the 180, 186, 78, and 52 is what we're doing. Remember, we distribute the scalar to every element inside. So G is going to equal 1.5 times 180, which is 270. 1.5 times 186, which is 279. 1.5 times 78, which is 117. And 1.5 times 52, which is 78. Okay, and there you have your goal matrix. So your goal is to sell 270. Okay, and that's in that first quadrant, or that first element 1, 1. So that means your goal is to sell 270 120 gigabyte SSDs in June of next year. And to sell 117, okay, 256 gigabyte SSDs in June of next year. Okay, but that's total. It's not just in Boston, just in Chicago. That is the goal of the total. Okay. All right. So matrix or matrices. Organization is paramount, imperative, is a must. Okay. And understanding, especially when it comes to these word problems, understanding what each element means. Because if you don't understand what the matrix is representing, it's harder to walk through and be like, oh, this is the total sales. This is how I get my goal. What does each element represent? Okay, so organization to track all those things. All right, I will see you tomorrow.